Music is something everyone loves to hear. However, most do not know the various physics concepts that help produce these sounds. Music is made of sound and silence over time. To understand how music works, we really have to first understand how sound works. Sound is a wave, which is the disturbance that travels through a medium, most commonly air, and transports energy. Sound waves are caused by vibrations. A vibration originates from a starting object and transfers from particle to particle, making it a mechanical wave. Sound waves are longitudinal waves since they move parallel to the direction of the energy transport. So, the vibrating object pushes the surrounding air molecules forwards, transporting sound energy, which causes those molecules to push the ones surrounding them forward. This causes areas of clustered particles and unclustered particles. The high concentration areas are called compressions, and the low are called rarefactions. There are many characteristics of sound waves that give sound its character. The first being frequency. Frequency is a measure of how often the particles of a medium vibrate when a wave passes through them. A complete back and forth vibration from crest to crest is considered one wave section. The amount of these that occur per second is the frequency, and the unit for this is hertz, or vibrations per second. The period of a sound wave is the reciprocal of the frequency. It is the amount of time needed for one complete vibration to occur. Frequency determines the pitch of a sound, and a higher frequency would mean that there is a higher pitch. The human ear can detect sound waves from 20 Hz all the way to 20,000. In most Western music, a 12-pitch or tone system is used based on the ratios of wave frequencies which make up specific intervals between notes. Music is not a series of notes, but it's more of a series of intervals. If you take a song and raise all of the pitches a certain amount, it will sound just as harmonious as it did before, just in a different key. Here's an example. While the pitches each time the song was performed were different every time, the intervals between the notes were the same, which is why the melody could be recognized each time the song was played. This just shows the importance of intervals and how music is basically just built off of these. There are two types of intervals in music, consonant and dissonant. Consonant intervals are considered more pleasant sounding. The most consonant intervals are the octave, perfect fifth, and perfect fourth. Octaves sound like a higher or deeper version of a note, which is why they have the same letter names. The reason octaves are so complementary is because to go up an octave, all you have to do is double the frequency of a note. For example, an A can be 440 Hz, and the A an octave above would be 880, and below will be 220. The simpler the ratio between the two frequencies, the more consonant or pleasant sounding the two notes played together will be. In string instruments, a string that is half the length of another string would produce a sound an octave higher than the other string because it would be vibrating twice as fast. Western music creates other intervals based on the relationship between the root note and the octave. The next most consonant interval is the perfect fifth. This has a 3:2 ratio, so you would multiply the base note's frequency by 1.5. For a perfect fourth, there's a 4:3 ratio, so you would multiply the frequency by 1 1/3. This table here shows the rest of the ratios between the intervals. In our 12-tone system, between the root and the octave, each interval is divided equally as shown here. When two notes are played together, their frequencies are combined. This is called wave interference. The two waves are superimposed onto each other, and depending on the direction can either be constructive or destructive. Constructive interference is when the two waves are displaced in the same direction and would increase the amplitude of the wave. This is why when a band plays in tune, they can sound louder without even increasing the volume. The consonant intervals line up very well with each other, and the dissonant intervals do not as much. When two notes are played out of tune, you can actually hear the phasing of the waves being played at the same time. The instruments that I play are brass instruments. All brass instruments have a mouthpiece, a bell, where the sound comes out, and tubing that controls the pitch. On the mouthpiece, sound is produced by vibrating or buzzing your lips on the mouthpiece. Many people believe that you just blow air through it, but if you do that, you'll just be left with the ominous sound of brassy wind. Many brass instruments have valves which, when pressed, alter the direction of the sound waves and can either decrease or increase the length of the wave's journey to change its pitch. On the euphonium, the second valve has the smallest amount of additional tubing. It decreases the pitch by a semitone or a minor second in terms of intervals. The first valve decreases the pitch by a major second and the third by a minor third. The first and the second valve's tubing is equal to the tubing of the third valve, which causes the same note to be played with this combination of valves, interchangeably with only slight differences. These three valves are used in combination to play all of the notes in our 12-tone system in various octaves. However, multiple notes can be played with the same combination of valves by either increasing or decreasing the frequency at which your lips vibrate. A technique that takes advantage of the sound waves is vibrato. Vibrato is the intentional slight changing of a note that gives it its wiggling sound. There are two common types of vibrato that alter different characteristics of the sound you're producing. The first being diaphragm vibrato, which uses your diaphragm to alternate between the amount of air you're putting into your instrument. This alters the amplitude of your wave. The other type, which is more commonly used, is lip vibrato. In this, you're wiggling your lips while buzzing to increase and decrease the size of the hole your air is coming out of. This alters the frequency of the wave as you are alternating between sounds lower and higher than the pitch you're initially producing. With all this knowledge of the behind-the-scenes factors of music, you're probably begging to hear something be played. So here is my performance of Fantasia di Concerto by Edoardo Boccalari on the euphonium.